Alright, so we're going to continue on with the Your Turn from section 8.5. We're going to be solving this next quadratic equation by putting it in standard form first. So I'm going to move everything over to my right hand side. So I'm going to add a negative 15 and add a negative 15, add a positive 2x and add a positive 2x because I make everything disappear from the left and reappear on the right. I'll put an equal in here so you see what I did was create an equal equation, and then 0 is equal to x squared minus 5 minus 2, which is 3x, and then minus 15 minus 3, which is 12. And I need the factors of 12 that are going to give me a difference of 3. And so we have, let's see, 1 and 12, 1 and 12, and 2 and 6, and 3 and 4. And so I have no factors that are going to give me a difference of 3. And so let's see, that's not going to work, is it? So in this case, because I couldn't factor it, there are no factors of 12 that give me difference of 3, I would actually have to use the quadratic formula on this, that a was equal to 1, and b was equal to a negative 3, and c was equal to a negative 12. And so here we have our x is equal to and negative of a negative 3 plus or minus, and then the square root of our negative 3 quantity squared, and then minus 4 times 1 times a negative 12, and then this is all over 2 times 1. So now we have a positive 3 plus or minus, and then the square root of, this is going to give me a 9, and that's going to give me plus a 48, and 9 plus 48, which is 57, and then that's all over 2. And it's very easy to see that this radical isn't a whole number, so you're not going to get 2 roots, and that means that this really doesn't factor. And so as long as everything worked out here and I didn't do any math wrong, that would be my solution. So let's make sure negative 15 coming over here, 15 minus 3 would give me 12, and then add 2, so 5 minus 2 would be 3. Yep, that's exactly right. So that one didn't factor. So we had to use quadratic formula. All right, on our next one, what we're going to see in this particular instance is that we have something factored over here. Now, a lot of students, what they'll try to do here is they'll try to set each factor equal to 10. That's not what we're doing. We're not using whatever the left side factor is equal to what's on the right. That's not what the zero factor property says. So in order to start this problem, what we have to do is we have to expand this out by distributing here. So we get z squared minus 9z, and then we're going to bring the 10 over to the other side, so we get minus 10 is equal to 0. And then once we have that, now we can refactor it. I know it sounds so painful, doesn't it? And so we can refactor it and then use the zero factor property. So I have the factors of 10 that give me a difference of 1, or of 9, sorry. So 10 and 1, so a negative 10 and a positive 1. And then I set each of those factors equal to 0, and I solve those very simple resulting equations, and I get that z equals 10 for the first one, and then for the second one I get that z is equal to a negative 1, and therefore if z is equal to a positive 10 or a negative 1, then we have a solution here. So just make sure that you didn't make that mistake of setting what's on the left equal to what's on the right. That's not what the zero factor property says. However, it is oftentimes mistaken for that. So now in the next video we'll do F and G, and then we'll continue on into problem number 2 if we have time.